Okay, welcome back to second semester geometry. And today what I hope to do is just kind of review some of the big items, some of the big topics, highlights of semester one in a short, at most 10-minute video. And as I'm going through some information, you're going to have basically it's going to be expected that you take some notes. I'm going to provide to you with a sheet that's going to allow you to follow along with this presentation, and you can make notes as we go along. So if you notice here on the board, we started off with basic constructions here in the beginning of the year in first semester. And three of the big constructions that we start off with dealt with constructing an equilateral triangle, doing a construction that basically requires you to split an angle in half, bisecting an angle, and then also finding the perpendicular bisector of a line. And so I want to go through those briefly and then continue to move on with some of the review, the highlights of the first semester. So you'll notice here on equilateral triangles, we use two things, a straight edge and a compass, and obviously a pencil, but the compass and the straight edge are used. And so what I'm going to do is go back to our construction website, and I'm going to show you two easy constructions, equilateral triangle and bisecting angle. So in order to construct an equilateral triangle, we start with just a segment. And we take the compass, and we're going to take the compass needle, and we're going to basically create a circle. Then we move the needle, and we see that we draw another circle, and then we're basically just going to connect these points and there's your equilateral triangle. Oops, sorry. You can see that your equilateral triangle is formed simply by taking and constructing two circles. So basically, a segment and two circles is how you do an equilateral triangle. In terms of an angle bisector, an angle bisector is simply starting with another circle, the circle beginning at the vertex, doesn't have to be a full circle. Basically, we just want an arc. And then we're going to take the protractor and at that needle, come out here a little ways and lock it. And I'm going to mark this and then move the needle over here. I'm going to mark that. And that point, this segment here that joins, that is your angle bisector. That's how you do an angle bisector. So there's two constructions that we should be able to do. Now, the third you can see in constructing a perpendicular bisector, basically it's two circles, and I'm going to let you sort of navigate towards reviewing how do we find the perpendicular bisector using a compass and a straight edge. You can see that the red line serves as the perpendicular bisector of the original line AB. And they're constructing two circles. It looks like they got a circle, this circle here with the radius of this length. And then they come back and they do the same thing with this circle using a compass. And these marks right here designate where they're going to draw the line. And that's effectively how you construct a perpendicular bisector. Okay? So, the circumcenter. Now, what is a circumcenter? Well, the circumcenter is effectively it's this point right here. And it comes from the intersection of three perpendicular bisectors. The idea of what's concurrent. In other words, concurrent means where points are coming together. This point, founded by the perpendicular bisectors of these lines, is called the circumcenter. And so perpendicular bisectors on a triangle form the circumcenter at that point of concurrency, the point where they all intersect at one spot. We also learned about the idea of what equidistant means. In addition, we also talked about something called the incenter. Well, the construction of three angle bisectors of a triangle also result in a point of concurrency, and we call that the incenter. And so, slightly different, we're actually taking the angle bisector, three bisectors of these angles, and at their point of intersection, right here, we call that the incenter. And so the circumcenter is found by finding the three perpendicular bisectors, and the incenter is found by finding the three angle bisectors. And the point at which they all intersect, that's the difference between those two. So I'll let you pause the video and write the difference between circumcenter and incenter in the space available. So also in the highlights of this first semester, ideas of vertical angles, they equal 180, and supplementary angles equal 180, and the angles at a point all add up to 360. As diagrammed here, 360, this is 180, and these two are equal. This right here should be over here. So keep in mind that this should actually be here. These are linear pairs, and so that's a mistake on the video there. I apologize. The linear pairs should be moved over. So figure A, vertical angles, they're equal. Figure B, they are supplementary angles and they're also linear pairs. And figure C, angles at a point add up to 360. And they allow us to create equations to solve for variables. Another big idea, dealing with parallel lines and a transversal, corresponding angles. First topic that we learned, these two angles are in the same corresponding location. That means they're equal. Same side interior angles. Same side interior angles. They add up to 180. And so B plus 48 is equal to 180. It allows us to solve for B. Other angle relationships that we learn. Alternate interior angles. The diagram is not showing up, so I'm going to have to add that. Other angle relationships. For example, alternate interior angles. So if we have two parallel lines and a transversal, alternate interior angles would be these two angles here. And again, if we have two parallel lines and a transversal, alternate exterior angles would be something like this. Alternate exterior angles. These two angles are equal. And so the diagrams didn't show up in the video, but there you go. Alternate interior angles are equal and alternate exterior angles are equal. Auxiliary lines are used. Review that. Sometimes useful when you're solving unknown angles. You can see the auxiliary line dotted out there. Allows us to find missing angles and the use of parallel lines and transversals. Another big idea was being able to use this information. I show an example in this one where I'm using two different methods to solve for angle B. Here's your first method, and here is your second method. So what I want to do is I want to finish this out by you on this sheet. Go ahead and use the concepts that we learned in semester 1 and solve for J. There's J and there's X in this particular problem here that I'll leave you with to fill out on your own. All right, so there you go. Sorry about the glitch on the diagram, but nevertheless, all right, here we go.